All right. Good morning. Good morning. So today we're going to talk a little bit about some chemistry concepts. So we're going to be looking at Avogadro's number and the mole concept. So with anything, we want to look at what's given to us and then what are we looking for. We don't want to skip steps. Chemistry isn't about speed. Chemistry is about being thorough when you do your work. So we want to be thorough. But a fast student or a student that works really, really fast is not going to be as effective as students that takes their time, does it correctly, and works thoroughly. So I always do my work out. I do it long, and that way I can see what I'm doing. If I make a mistake, I can see it. Um, and I'll always be a student that's smart or a student that works fast. All right, so let's take a look. So first thing I want to do is let's see what the given information is. We want to write it down because we want to be able to see it. And then these are one-step problems. Eventually, we're going to get to three-step problems, and that's where we really need to keep track of everything. So some given information that we have here. They've given us 46 grams, and that's going to be of sodium. So we're converting this from the language of English into the language of chemistry. I love English language arts, but this is a lot of words. We want just the nitty-gritty stuff. What are they asking me to find? They want me to convert that into moles. Okay. So I know to do that, I need molar mass. So if we take a second and we look on the periodic table, sodium's mass is 23. 22.99, but in science we pretty much say it's 23. So 23. So for molar mass, for every 1 mole of sodium, that's going to be equal to 23 grams. All right, so this is an equality. I can use this as a ratio as well. 1 mole Na, that's going to be equal to 23 grams of Na. How about that? All right, so now we want to go ahead and start setting up our problem. So step number 1 is to rewrite the given and draw our T-chart. Easy peasy, no problem. So we're going to rewrite the given. And we draw our T-chart. T-chart is just a capital T that's falling over to the left. So we had some capital T, and then he's going to fall over this way. And then when he falls on his side, he lands like that. Given units always comes on the bottom. Unknown unit always goes on top. All right, and then now that we have the units, I always underline, I always draw an arrow. The whole thing, the unit and the species come over. This is really important because it's going to allow us to do those 3 steps problems and keep track of everything. This is like a chart for me. And then what's my unknown? Molar Na. Now all I do is just match the numbers. So I go up here and I look, 23. And then some people might put on the top, some people might put on the bottom. How do we know? Matching, not chemistry. We didn't go down to Georgia Tech to get this. Matching from elementary school. It's easy. 23, does that go with mole Na or does 23 go with gram Na? Okay, let's see. 23, it doesn't match mole Na, that's a 1. 23 goes with gram Na. Okay, no rocket science. Not yet. Not yet. We're getting there, but not yet. 1 mole of Na. So this 1 goes with mole Na, all right? And then, okay, it doesn't go with gram Na, and there's only 1 spot left to put it in. So this spot is already taken up with a number. This one needs 1 mole Na. Mole Na gets us 1. Okay, now everything matches, no problem. I like to do units first because they're easiest. Gram Na cancel with gram Na, and I'm left with mole Na. And then now I'm just going to express this mathematically. 46 times 1 is 46. And I could just express this as a fraction, 46 over 1 if I wanted to. So this would be 46 times 1, numerator times numerator gives me my numerator. 46 times 1 gives me numerator. And then 1 times 23, that would give me my denominator. So 46 over 23, okay, that's just a fraction. That's a 2. So that's going to be 2. So we'd have 46 times 1 at the top, 1 times 23 at the bottom, 23, and then we express that, 2. No problem. This is easy. Just slow down and take your time. This is easy. This is easy. All right. And then now we're getting into Avogadro's number. So let's take a second and let's look at what Avogadro's number is. Avocado. Oh, that's a fruit. Avogadro's number 6.2 times 10 to 23. And this could be particles, atoms, molecules. All right. So 6.02 times 10 to the 23rd, and that's going to be equal to 1 mole. And that's of any substance, sodium, chlorine, any substance. All right, so we know Avogadro's number, that's going to be equal to 6 point, that per 1 mole. And I can write this as a ratio. This is just an equality. So let's take a second. Let's write this as a ratio. 6.022 times 10 to the 23rd. And we're dealing with atoms, so I'm just going to go ahead and put atoms. And that's going to be for every 1 mole. All right, so atoms and moles, and we're only dealing with sodium, so we don't need to specify. Given information, they gave me 3 moles of Na. Unknown information, they want me to find atoms. So how many atoms? Okay, that's easy. So step number 1, never science. It's always just effort. We're going to rewrite the given and draw a T-chart. So for any student who says, hey, I don't understand, you understand. We can rewrite this. You might not have written your given, so you might not know how to do that part. But if you wrote your given, rewriting it is not hard. 3 moles, Na, and then draw our T-chart, ABCs, 1, 2, 3. That's from elementary school. We just put it on the side. This unit always comes over. So much so I always underline it. And then my unknown units goes on top. All right, so now I just need to match. So this is 1 mole. And then this would be 6.022 times 10 to the 23rd. Oh, this is too easy. This is too easy. All right, mole of Na cancel. Mole of Na cancel. No problem. I'm going to be left with this unit here. Atoms of Na. And then now I just need to express these terms mathematically. We have 3. And then we have this value here. So I, a lot of times, just leave it in scientific notation. That's fine. 18.066 times 10 to the 23rd. Numerator times numerator is the numerator divided by, we could put this over 1, divided by 1. So this should just be itself over 1. So I'm not going to put it over 1. So anytime I see 1s at the bottom, I just ignore it. They're themselves. Wow, that was pretty easy. That was pretty easy. Let's do another easy. Let's see if we're doing hard. Okay, so this is molar volume. I knew this was molar volume because I saw the liters. He writes his own question. Well, that's, even if I didn't write this question, once I see liters, I know we're talking about molar volume. Molar volume tells me that for a gas at room temperature, or at STP, we have 22.4 liters. That's going to be equal to 1 mole. If I wanted to write this as a ratio, 22.4 liters for every 1 mole. Oh, this is too easy. All right, so first step is write our given and unknown. All right, the given information is 44.8 liters. And we're only dealing with sodium, so I don't need to specify. The unknown is they want me to convert that into moles. Easy, man. All right. Step number 2, no chemistry, no science. This is just effort. Rewrite my given and draw my T-charts. All right. And then now fill in my units. Liters is here, so I underline it. Then unknown units at the top. And now, no rocket science, no chemistry, just matching. What number matches my L? I'm just going to go over here to my equality and my ratio. Okay, there's a 1 right here. That's not an L. This has an L. Okay, this is my value here because it matches 22.4 liters. And then now what number matches my mole? Mole has a 1. And then now we just 44.8. Well, liter and liter going to cancel. And we're left with mole. Do my units first. Take care of the easy stuff. 44, and I'm just going to go ahead and express it as a fraction. 44.8 times 1. That's just 44.8. And then 1 times 22.4. That's just 22.4. So if we reduce that fraction, that's going to be 2 moles. So for every 44.8 liters of sodium gas, we're going to get 2 moles. So easy, so easy. All right, so let's go ahead. We'll get ready for, we're going to do stoichiometry next. We'll rewind that. Okay, we're back. So now, next we're going to do stoichiometry, and that'll give us some mole-to-mole conversions and also moles of one thing to grams of another thing. So stay tuned. Get ready for the next video.